Hey Vex Nation, welcome back to the 2026-2027 video walkthrough of the Vex V5 Robotics Competition HeroBot. In this second part of the series, we're going to discuss some of the pitfalls of this year's HeroBot Flex, and how teams might look to improve the design and performance of the robot should they choose to field it. If you haven't checked out the reveal video for this year's game Override, or read the game manual, this might be a good time to do so. We gave a brief overview of our goals for the HeroBot program in the last video about how this is intended to provide students an accessible means to develop an understanding of the game and how to play it. The HeroBot is also intended to be a starting point that teams use to iterate upon and make their own over the course of the design process. It is highly encouraged that teams work to modify the HeroBot to better fit their design goals, and this video will serve as a platform to discuss how you might approach what to change. We'll work through the mechanisms and subsystems in the same order as the previous video, and discuss the changes teams may look into implementing for each part of the robot. As is the case with many of the HeroBot drivetrains, this robot base is primed for a redesign. The HeroBot is constrained to using only the parts available in the Vex V5 Competition Starter Kit, but it's our hope that you have more parts available for use. If you do, the first thing you should consider is adding some more motor power to the drivetrain. Pay attention to the new motor allocation rules for this year's game, however, as you can't place as much power here as you previously were allowed. Teams might consider using the 55 watts of motor power allocation in a few ways, doubling the power to use 44 watts, or even designing an H-drive that uses that last 11 watts to power a strafing wheel to create a truly omnidirectional drive base. The claw is an effective starting place for game piece manipulation, but in its current implementation on this robot, it certainly has some shortcomings. One of the key elements of this year's game is going to be object reorientation, and currently, Flex relies solely on picking objects up in the orientation they will be scored. It cannot pick up a game piece and intentionally flip it to score the preferred color. Teams may get creative in mounting the claw to a rotational joint that allows it to spin 180 degrees with another motor, or you may choose to design an entirely new end effector that better suits your needs. We briefly discussed how the arc of the 4-bar linkage may cause some trouble in game piece manipulation in the last video. Teams may prefer to find a new lift design that keeps the game piece moving up and down purely vertically with no horizontal movement. An elevator lift similar to some of the high-stakes climber designs, or a double reverse linkage that was previously popular in some of the older Vex games may be interesting places to look for inspiration here. The wheel to actuate the toggle should really be on its own motor, and I hope that teams who explore building Flex decide that this is one of the first improvements they will make. Flipping toggles is likely to be one of the most effective ways a HeroBot can contribute to an alliance, and improving this mechanism is going to be one of the most valuable changes you can make. This will allow teams to explore some more variance in wheel speed, change the wheel type, and explore variables that are not possible within the limitations of the V5 Competition Starter Kit. The last key area for improvement with Flex is the integration of sensors and more complex software. All competitive robots can garner benefits from integrating more sensors and utilizing those sensors in software to improve autonomous routines or create automation during driver control. Rotation sensors can be added to the arm, an inertial sensor can be added to the robot base, and you might even look into incorporating a vision sensor to accurately determine the color of game pieces that are spread around the field automatically. As I said in the first video, Flex is versatile and capable, but I hope it's even more obvious now that it has many areas for improvement that teams should look to implement. The bones for a good competition robot are here. We hope teams take those bones and make this design their own, and bring effective robots to competitions that can contribute to winning matches. Thanks for watching. Be sure to like, comment, subscribe, and stay tuned for more Vex Robotics content.